Hello everyone. So in this video, I'm going to discuss one of the problems from IMO 2023, which was the exam was held last week. So I'm going to discuss in this video the first day first problem, which is a number theory problem, and it was to determine all composite integers n greater than 1, such that the like you have all these di's to be the divisors of n, and they are arranged in increasing order. D1 is 1 and dk is n, and they are arranged in increasing order. And also it's given that di divides the sum of the next two divisors, that is di plus 1 and di plus 2, for every I greater from 1 to k minus 2. Okay, so basically you see, if we have to attack this problem, where do we attack it? The only place is that di divides di plus 1 and di plus 2. Okay, so because otherwise, like all what do you like, this is, I mean, in the process you can use that the divisor in increasing order or whatever. Okay, and the rest, there is no other information. We have to figure out to composite integers n greater than 1, and that's it. Because so always you have to identify the main core of the problem where we can attack the problem. So first, writing d1, so this is very trivial because d1 is 1. So what would you do? Like, it will divide anything. Okay, so d1 divides d2 plus d3. Similarly, d2 divides d3 plus d4, and so on and so forth. So the last one, dk minus 2, divides dk minus 1 plus dk. Now what is dk? Okay, so as like d1 is 1, similarly dk is n, correct? So dk minus 2 divides dk minus 1 plus n. So here you see that, like, we know that all are the divisors of n. So dk minus 2 divides the sum as well as it divides n. So that implies that dk minus 2 divides n. Of course dk minus 2 divides n. So that implies dk minus 2 divides dk minus 1. Okay, so here what are we getting then? Try to understand. We have d1 divides d2, and we have this holds trivially. Okay, so this and also we have dk minus 1 divides dk. Okay, nothing very unusual because dk minus 1 is a divisor of n, so it divides n, which is dk. And now we are also getting this relation, that is dk minus 2 divides dk minus 1. Okay, so dk minus 2 divides dk minus 1. So then what? Then we have something, that is, suppose if we write this, that is let's say dk minus 2, so yeah, that divides dk minus 1. Now how can we utilize this? That is, we know something about the divisors. That is, if we combine the first divisor with the last divisor, then the product is n. Okay, and then second divisor with the second last divisor, if we multiply, then the product is n. So the concept that we use to figure out the product of all the positive divisors of a natural number. Okay, so the same concept. Okay, so from there we know, like we have learned, so those who have learned these things, these basic things, knows that d1 dk, of course that product will be n, but d2 dk minus 1, that product will be n. So from there we are getting, so let me write this up. So let's see, we are getting d2, the second one combines with the second last one, dk minus 1, and that is equal to n, and which is also equal to d3, and d3 will combine with the dk minus 2, the third last. And now we have this relation, that is dk minus 2 divides dk minus 1. So let's dk minus 2, after dividing dk minus 1, suppose it's L. So now we have d2 times L is equals to d3. So that obviously implies that d2 divides d3. Okay, so where did we write here? So d2 now divides d3. So now you see that this, like, a sequence is forming, that the first divisor is dividing the second divisor, the second divisor dividing the third one. Also from the back we are seeing that the second last is dividing the last, the third last is dividing the second last. So now will this relation continue? That's the question. Okay, so what can we do here further? Now I mean, while first solving, I also did for, like, I checked for how we can go from d3 to d4, as well as like how we can show d k minus 3 divides dk minus 2. Okay, so so I'm not going to waste time and show that process. So I'm just going to jump to the general ith step, and from there you can put I equals 3 or 4, whatever, to see the base steps. Okay, so I'll be taking I to be let's say greater than equals to 3. Okay, and I'll say that, like, d1 divides, so it will be given that d1 divides d2, d2 divides d3, and suppose d. I'm writing this in this way, so just for you to understand. Okay, I can write it in separate ways, but just understand the notation what I'm trying to convey here. Okay, so yes, we were discussing that, yes, di, so di minus 1 divides di. So from the front, this is the relation which will be given. So just as in the third step we are taking. Okay, so yes, and this is given, and from the back again it will be given that now we'll have from the back also I steps. So that will be dk, so dk minus 1 divides dk minus 2 divides dk minus 1, and so on so forth. So the last one will be dk minus I minus 1 in bracket, which is basically dk minus I plus 1. Okay, so try to understand the pattern there also, like 3 and then dk minus 2. So if 3 is I, then we have dk minus 3 in bracket 3 minus 1. Okay, so that's the thing. So let me put a bar in between. So this is given. Okay, so from the front, from the back, this divisibility is given. Now we will be trying to show that the here the previous one, that is this is dk minus I plus 1. So the previous one, which is dk minus I, so that divides this, and also we will show that di divides di plus 1 if this relation is given. So with if I am able to prove this, then so from here you will be able to show that d3 divides d4 and dk minus 3 divides dk minus 2, and so on and so forth. Okay, so let's show the I plus 1th step. Okay, so now for the I plus 1th step, what we are doing is we are going to show that so this is nothing like I jumped to this anyway, like I figured out for what was happening for when we are going from I equals 3 to I equals 4, and from there I generalized. Okay, so what I am going to do now here is, I know that di minus 1 divides from the relation which was given, that is it divides the sum of the next two divisors, so which is di plus di plus 1, right? And now it's given that di minus 1 divides di, so that implies that di minus 1 will divide di plus 1, but we have to prove di divides di plus 1. Now we have di minus 1 divides di plus 1. Okay, so now again we are going to use the relation. So the relation is that di product with dk minus I minus 1 is equal to n. Okay, and that is basically di dk minus I plus 1 is equals to n. So we'll try to use this relation. So we have di minus 1 will club with dk minus I minus 2, and that will be equal to di minus 1 dk minus I plus 2, and that product is n, and that also I am going to write it. Now I know that di minus 1 divides di plus 1, so I'll try to use that. So I can write di plus 1 will combine with dk minus I plus 1 minus 1, which is basically di plus 1 will combine with dk minus I to give the product n. Now try to utilize these two. We know that di minus 1 divides di plus 1. So suppose this is L dash. So we are getting that so we are getting dk minus I times L dash is equals to dk minus I plus 2. So from there I am getting that dk minus I divides dk minus I minus 2. Okay, and now I know that the one that was given to me, that is dk minus I, the property, that is the next, it divides the sum of the next two. So dk minus I plus 1 and plus dk minus I plus 2. Now dk minus I divides this, so it divides this whole thing, so it implies that dk minus I divides dk minus I plus 1. Okay, so we are done with this side, that is this number is divisible by dk minus I, the previous one. Okay, this is nothing but dk minus I plus 1, so the previous one is dk minus I. So this side is shown, only we are left to show that di divides di plus 1. So for that what we'll try to use is that we are done till here. So again we will try to use that di times dk minus I plus 1 is equal to n, and that I am going to combine with di plus 1, because I have to show that di divides di plus 1. So di plus 1 combines with dk minus I, and now you see that here dk minus I divides, we just showed that dk minus I divides this. So suppose this divides this, and suppose the quotient is L double prime. So here it implies then that di divides di plus 1. Okay, and so we are done with the I. So if the ith step is given, we are done with the I plus 1th step. Okay, so yes, where I is greater than or equals to 3, and so by inductive way, inductive process, I mean this is just induction, nothing else. Okay, so we are done. That is, we have proved that this happens, this relation happens, that every divisor divides the one next to it. Okay, and so now think that when can this happen. So suppose we have to figure out all the composite numbers. Now if a composite number, if it's having more greater than or equals to 2 prime factors in it, suppose p and q are the 2 prime factors in it, so p is strictly less than q, suppose, okay, without loss of generality. And now, so, and suppose let's assume that p is the smallest prime present in it and q is then the second prime, second smallest. Okay, so what we can say is that if this relation holds, then obviously there will be this divisor p, okay, which will be coming first after 1. This p will be coming because it's the smallest prime which is present in n, and then the powers of p can come or whatever. So after that, like this will be less than, it can come if the powers of p are still less than q, so then it can come, but then after a certain step, then q will, so I mean the divisors that is P will divide the next divisor, and so on and so forth, and then after a certain step this Q will come, okay, and that would imply that P will divide Q. But P and Q are two prime numbers and they are dividing each other, so that's a contradiction, okay. And so a number can't have more than one prime factor. So there we can say that like the number has to have only one prime factor. And so again we have to determine all composite integers. So if P is a prime and we take P to the power n, where n is greater than equals to 2, so then these are prime powers, these numbers are prime powers and they are composite, and since it can't have more than one prime, so this is the only choice left, right? And yes, so all the divisors of this number are of the form what? 1, p square and so on till p to the power n, and yes, you can very well see that all these relations that is given, it trivially holds, okay. Not only the successive divisors divides the next one, but also the sum of the next two divisors is also divisible by the previous one, okay. I mean that you can very well see, like pk divides pk plus 1, p to the power k plus 1, sorry, p to the power k plus p to the power k plus 2, okay, because you can take a p to the power k common from here easily. So this holds, and so the only numbers that satisfies this is they are of the form they are prime powers and composite, okay. So yeah, I hope I haven't made any mistakes anywhere. So please do comment how you liked the solution, and if you didn't understand anywhere, first I would like to tell you that try I with some small values, like maybe 3, see how from 3 to 4 things are coming from, then try from 4 to 5, and you'll start developing these ideas how I came across this. And yeah, and the rest is like once you get that, the rest is trivially done, okay. So yeah, thanks for watching, and keep watching and keep learning, and see you in the next one.